Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice all your entrance exam question papers because it contains papers along with their detailed PDF solutions. For a better preparation of your exams, you must download our app. The link is available in the description box. Students, today I'll be solving JEE Mains 31 Jan 2024 Shift 2 paper, evening paper. In this particular video, I'll be solving the mathematical part, that are the maths questions. So let's start with the first question. A very best of luck. Here we go. The question number 1 says the number of ways in which 21 identical apples can be distributed among 3 children such that each child gets at least 2 apples. So you are having 3 children. Let's say this is 1, 2, and the third one. So this is having 2, 2, and 2. So 6 apples already have been given to them out of the 21 apples. So how many apples are remaining? 15. You are left with 15. Now 15 has to be distributed among 3 children. So this distribution can take place in 15, which are left, plus 3 minus 1 C2. That makes 17 C2, which is equal to 17 factorial upon 2 factorial into 17 minus 2, that is 15 factorial, which is nothing but 17 into 16 upon 2, 17 into 8, that gives you 136. So that makes D option to be the right answer. Hope you're clear with this. Let's move to the next question. Question number 2, let A be the point AB, B, and this is the point C, respectively, denote the centroid, circumcenter, orthocenter of the triangle. And the distance of this point P from this line measured along this line is equal to. So you are having 3 points in the question. First is A point, which is your centroid, and then you have the point B, which is 3, 4. That is your circumcenter. And then you have the C point, which is minus 6, minus 8, which is your orthocenter. Now, you know one thing, that the centroid divides the circumcenter and the orthocenter in the ratio 2 is to 1. That means the centroid, if I take it over here, this is the point AB, this is centroid, divides your orthocenter and your circumcenter, which is given by this point in the ratio 2 is to 1. So let's find out the coordinates of A. This will be given by 2 into 3 plus 1 into minus 6 divided by 2 plus 3, that is equal to 0. Similarly, the B point will be given by 2 into 4 plus 1 into minus 8 divided by 2 plus 1, again is equal to 0. So your A point is nothing but the origin, and your P point, which was given by 2A plus 3, 7B plus 5, that becomes equal to 3 and 5. This is your P point. Now, see what was there in the question. You were asked, basically what were you asked in the question? The distance of this point from this line, which is parallel to this line. So understand two things. We'll always go with what is asked in the question. We are asked the distance of this point from this line, and you are given a specific thing measured along this line. One problem was there. I did not have the coordinates of A. To know the coordinates of A, I had to find out the value of A and B, and where were A and B? They were lying over here. So from this first part of the question, I calculated A and B, and then I used that A and B in the second part of the question to get the value of your point P. Now, I want the distance of this point P from this line. There is a condition that the distance is not a perpendicular distance. Now the distance is measured along this line. It looks something like this. This is the point P, which is having the coordinates 3, 5. You want, this is the line. Let's say this line looks something like this. Let's say this is the line. 2x 3y minus 4 is equal to 0. Now this, let's say this is the point of intersection Q over here. This distance has to be measured along this line, that is x minus 2y minus 1 is equal to 0. That means they are given that these two lines are parallel to each other. That means they will have the same slope. So what is the slope for this line? X minus 2y minus 1 is equal to 0. 2y is equal to x minus 1. This is equal to this. So your slope is equal to 1 by 2. That gives you tangent theta is equal to 1 by 2. So for this line PQ, you have slope that is equal to, you can say tangent theta, and this is 1 by 2. Okay, now let's calculate the, you can say squaring both sides. You have tangent square theta is equal to 1 by 4, or this is 1 plus, no, adding both sides 1, you will get 1 plus tangent square theta is equal to 5 by 4. This is nothing but your secant square theta. 1 plus tangent square theta is equal to secant square theta. So your secant theta will be root 5 by 2, or cos theta will be equal to 2 upon root 5. Similarly, applying cos theta is equal to root of 1 minus sine square theta. Like this. You will calculate that doing the whole calculations. Sine theta will be this value, 1 upon root of 5. Hope you're clear till here. Now, what do you need? Let's say this is the distance r. Basically, you have to find out this r. Let's go on to find out r. Now I have the point P, but there's a problem. What is the problem? I don't have any particular formula for that. What will I do? Let's find out the parametric form of this point P, because I don't want the perpendicular distance. I want the distance in which I am given the angle theta. So remember, I got the value for sine theta as 1 by root of 5, and cos theta was equal to 2 upon root of 5. All right. So the parametric form that's given for the point P as 3 plus r cos theta, 5 plus r sine theta. Now this point P, it satisfies this equation because I have taken the parametric form of it. So this will be given by 2 into 3 plus r cos theta was 2 upon root 5 plus it was 3. 3 into 5 r sine theta, which is equal to this, minus 4 is equal to 0. 6 plus 4 upon root 5 r plus 15 plus 3 r upon this is equal to 4, or you will have a 7 r upon root of 15 is equal to minus 17. That gives me r value as minus 17 root 5 upon 7. So this is the answer to the question. See, this is r is a distance, so I will take the modulus value. It can't be negative. This is 17 root 5 upon 7. So you have option C as the right answer. Hope you're clear with this. Let's move to the next question. Question number 3, let Z1 and Z2 be two complex numbers such that their sum is equal to 5, and Z1 cube plus Z2 cube is equal to this complex number. You have to evaluate Z1 power 4 plus Z2 power 4's modulus. That's the magnitude. So let's start. You are given Z1 plus Z2 is equal to 5, and you have Z1 cube. Z2 cube is equal to 20 plus 15 iota. You can write down Z1 cube plus Z2 cube as Z1 plus Z2 whole cube minus 3 Z1 Z2 into this. So you already had this becomes Z1 cube plus Z2 cube. This is equal to 5 cube, that is this much, minus 3 Z1 Z2. This is again 5. I will write it here. Anyways, this is given to you as 20 plus 15 iota. This is equal to 125 minus 15 Z1 Z2. So you will have dividing both sides by 5. You will get 3 Z1 Z2 is equal to 25 minus 4 minus 3 iota, which is 21 minus 3 iota. So you have Z1 into Z2, the product of them. This is dividing both sides by 3, 7 minus iota. Now, let's do one thing. Let's keep this thing in 9 because I got this value Z1 into Z2. Let's solve Z1 plus Z2 square. This is equal to 5 square, which is equal to 25. This makes it Z1 square plus Z2 square plus 2 Z1 Z2 is equal to 25. This is Z1 square plus Z2 square. Do I have the value of it? No, I don't. All right. So Z1 square plus Z2 square, let's write it as such only. I know this is equal to 7 minus iota. So this is equal to 14 minus 2 iota is equal to 25, or Z1 square plus Z2 square is equal to, this becomes 11 plus 2 iota. All right. So let's do the square of it. Z1 square plus Z2 square whole square. This becomes equal to 11 plus 2 iota whole square. This makes Z1 power 4 plus Z2 power 4 plus 2 Z1 Z2. I can write it like this square. This is equal to 121 plus 4 iota square plus 44 iota. So this is, let's write it as such because I need to find out this only. Z1 into Z2, that was equal to 7 minus iota whole square. This is equal to, this was minus because iota square is equal to minus 1. So this will be 121 minus 4, that is equal to 1, 1 and 7 plus 44 iota. This makes it Z1 power 4 plus Z2 power 4. This is equal to 2. Let's keep outside 49 minus 1. Remember, because iota square will give you minus 1. So this is minus 1 minus 14 iota is equal to 117 plus 44 iota. Or you have Z1 power 4 plus Z2 power 4. This is equal to 117 plus 44 iota. This becomes 48 multiplied by 296 minus 96. And here will be plus 28 iota. This will on subtraction of both of them, you will get here will be 1, yeah, and the 21. Okay, so here you have 21 and this will give me 72 iota. Z1 power 4 plus Z2 power 4. Now you have to find out the magnitude of it. Z1 power 4 plus Z2 power 4. Magnitude, this is given by root of 21 square plus 72 square, which is equal to root of 441, and 72 square is 5184. That gives me root of 5625, which is equal to 75. So that's it. This is what you needed to find out in the question. The magnitude of this is 75, and you have option B as the right answer. Hope you're clear with this. Let's move to the next question. Question number 4, let a variable line passing through the center of the circle, this meets the positive coordinate axis at the point A and B. Then the minimum value of OA plus OB, where O is the origin, is given by. Okay, so you are having this circle, x square, y square minus 16x minus 4y is equal to 0, meets the positive coordinate axis at the point A and B. Then the value of O and OB. Fine, so here you have and the center of the circle is given by minus g minus f minus half the coefficient of x, which is 8, and minus half the coefficient of y, which is 2. So that means this line, the variable line passing through the center of the circle. So this line passes through, this was your center of the circle. So line passes through this point. Okay, now let's frame up the equation of the line. Y minus y1 is equal to m into x minus x1. So y minus 2 is equal to, I don't know the slope, x into m into x minus 8. So for the x-intercept, now this line have some x and the cuts the it said meet the positive coordinate axis at the point A and B. So let's say the x-intercept, it will be given by, for the x-intercept, I'll be putting y is equal to 0. So on putting y is equal to 0, you will have -2 is equal to m into x minus 8, or you will have -2 upon m plus 8 is equal to x. So for x-intercept, you have this as the value of x, and of course the y will be 0. And for the y-intercept, I'll be putting x is 0. So this makes y minus 2 is equal to m into minus 8, or y is equal to minus 8m plus 2, and x is equal to 0. This is the y-intercept. Now, you are having then the minimum value of OA and OB. O is the origin, it is given, and this is your point A. Let's say this is your point A, which is -2 upon m plus 8 comma 0, and this is your point B, which is 0 comma minus 8 m plus 2. Done. So you are asked about the minimum value of OA plus OB. Let's first of all find out OA and OB. See, O is the origin. So what will be the distance OA? This will be given by root of 0 minus 0 minus 2 upon m plus 8 minus 0 whole square plus root of this will be minus 8m plus 2 whole square. Because O is the origin, so I'm not writing the zeros over here. Hope you can do this thing. Okay. So this will be given by minus 2m plus 8 plus minus 8m plus 2, or this will be 10. This will give me 10 minus 2 upon m minus 8m. Right? Now, for the minimum value of it, what we need to do? Yes, I will go with finding out the derivative of it. So this was, let's say, your f of m. Let's find out the derivative of this function m. This will be given by 0. Like 10's derivative will be 0, and this will be given by 2 positive, because minus and minus will cancel, 2 upon m square minus 8. This will be 0. So this gives me m square, let's write it, 2 upon m square is equal to 8, or you will have m square is equal to 1 by 4. That gives you m as plus minus 1 by 2. So the slope, it can have the positive or the negative value. For the minimum, I'll be taking the slope as like m as this minus 1 by 2. So taking m as minus 1 by 2, what is Fm equal to? That was equal to 10 minus 2 upon m minus 8m. So f of minus 1 by 2 will be given by minus 2 into 1 upon minus 1 by 2 minus 8 into minus 1 by 2, which will be, this will be 10 plus 4 minus minus plus 4, that is equal to 18. So this is the answer to the question, option B. Hope you're clear with this. Let's move to the next. Question number 5, let f and g be two functions such that from 0 to infinity to r, these are two functions defined by fx as this and gx as this. You have to find out the value for this expression. You're having fx is equal to integral minus x to x. This is an even function, so I can write it like this, 0 to x mod of t brackets t square into e power minus t square dt. So let's do one thing. I'll integrate, differentiate both the sides. Differentiating both sides. So on differentiating both sides, you will get f dash x is equal to twice of this will be given by mod of x minus x square whole under the bracket e raised to power minus x square, not dx, it will be there. Okay. So yeah, similarly, you have the second function gx as integral 0 to x square t raised to power 1 by 2 into e raised to power minus t dt. Again, differentiating both sides. You will have g dash x is equal to, this will be given by x because t square, that is x square raised to power 1 by 2, this will give me x only. X into e raised to power minus x square into x square, this is given by minus 2x. Okay, and minus minus they will cancel out. Okay, fine. So this is that's it. This is your g dash x. Let's say add up both of them, f dash x and g dash x. So these are the two functions. Let's add both of them. You will get 2x e raised to power minus x square minus 2x square e raised to power minus x square plus 2x square e raised to power minus x square. This is equal to 2x into e raised to power minus x square. This is equal to your f dash x plus g dash x. Actually, in the question, what I want is fx plus gx. So for that, what I have to do? I have to integrate both sides. Integrating both sides, you will get fx plus gx is equal to, this will be, I'll be taking 2 outside. Let's say this is, see, I'm putting the integral over here. 2 I'm taking outside. Now the limits over here will be 0 to x square. And this is given by e raised to power. I will not take x square over here. Let's say some another alphabet or variable over here. This will be integral of 0 to some another variable alpha. 2 I'm taking outside, or let it be inside only. 2 x this. So now I'll do what? I'll put x is equal to, x square is equal to this, x square is equal to t. So you will have 2x dx is equal to dt. Also the limits will change. When x is equal to 0, t is equal to 0, and when x is equal to alpha, t is equal to alpha square. So now your fx plus gx, this turns out to be this whole integral. Now this will be 0 to alpha square, and inside you will have e raised to power minus this dt. Okay, now it's super easy. E raised to power minus t divided by minus 1. So this is over here, and the limits 0 to alpha square. So this will be given by, I'll put t back. What was your t? T was equal to x square. So this is equal to e raised to power minus x square. And here is alpha square 0. Okay. So this will give me e raised to power. No, there is no need to put this x square thing. It will be like I have utilized using this. So it will be e raised to power minus alpha square minus of minus e raised to power 0, which will give me 1 minus e raised to power minus alpha square. Okay, now your alpha is what? This is your over x. If I replace this alpha by x, because this is a function of x, right? G of x. So this is equivalent to 1 minus e raised to power minus x square, or whatever this function is at this place. Okay. So you have to find out f of log of 9 plus g of log of 9 under the root. This is equal to 1 minus e raised to power minus root of log of 9 whole square, which will be equal to 1 minus e raised to power minus this, or this is equal to 1 minus e raised to power log raised to power log 1 minus e raised to power natural log 9 raised to power minus 1, 1 minus e raised to power, this is log 1 by 9, or this is, e raised to power log of any variable is equal to that variable only. So this is 1 minus 1 by 9. This is equal to 8 by 9. Now one thing, this is what you have to find out the value of this expression. There's a slight misprint over here. This has to be multiplied by this expression actually is 9 into this expression. Okay. So according to that, this expression will be, this was your f of root of natural log 9 plus g of root of natural log 9. This whole has to be multiplied by 9. So this will be equal to multiply by 9. That gives you 8 as the answer. So this is the answer to the question. Option C is the right answer. Hope you're clear with this. Let's move to the next question. Question number 6. Let alpha, beta, gamma be the mirror image of this point on this line. here is supposed to be equal to sign, then what is the value for this expression? So this is your line x minus 1. Let's draw the figure first. Let's say this is the A point, this is 2, 3, 5, and this is your line, which is given by x minus 1 upon 2 is equal to y minus 2 upon 3 is equal to z minus 3 upon 4. Let's say that's equal to some lambda. So from here, x is equal to 2 lambda plus 1, y is equal to 3 lambda plus 2, and z is equal to 4 lambda plus 3. So this is this line, and let's say this is the image, this is B point, alpha, beta, and gamma. This is the image of the point A on the given line. So what will be the AB vector? Given in the vector form, A will be alpha minus 2 I cap, beta minus 3 J cap, gamma minus 3 A cap. Now, if I see this point on this line, so you will be having alpha minus 2 into 2 plus beta minus 3 into 3 plus 4 into gamma minus 5 is equal to 0. 2 alpha minus this, 3 beta minus 4, 4 gamma minus 20 is equal to 0. Or you have 2 alpha, 3 beta, 4 gamma is equal to 33. So this is the answer to the question. Option B is the right answer. Hope you're clear with this. Let's move to the next question. Question number 7, let P be the parabola with the vertex 2, 3. This is the vertex of the parabola. Directrix 2x plus y is equal to 6. This is the directrix 2x plus y is equal to 6. Let an ellipse x square upon a square plus y square upon b square is equal to 1, where a is greater than b is the of eccentricity 1 by root 2 passes through the focus of the parabola, then the square of the length of the latus rectum of the ellipse is equal to. So first of all, let this z be the point, be the point of perpendicular from the vertex 2, 3 to this directrix. So you will have x minus 2 upon 2 is equal to y minus 3 upon 1 is equal to minus of 4 plus 3 minus 6 divided by 5. So on solving, this will be x minus 2 upon 2 is equal to y minus 3 upon 1. This will be equal to minus 1 by 5. From here, the value of x is equal to minus 2 by 5 plus 2, and y will be equal to minus 1 by 5 plus 3, which is equal to, this will be 14 by 5, and x will be equal to 8 by 5. This is the value for z. 8, 8 by 5 and 14 by 5. Okay. Now, 2, 3, this is the midpoint of this z and the focus. Let's say the focus is alpha and beta. So 2, 3, let's write this as well. This vertex is midpoint of z and the focus. So alpha, beta, let's say I can calculate this because this is 1:1 ratio. This will make it, give me a minute. Okay, so you will have a 2 is equal to 8 by 5 plus alpha into divided by 2, or you will have 8 minus this is equal to alpha, or you will have 12 by 5. This is the value for alpha. Right? And similarly, let's calculate beta also. You will have a 3 is equal to 14 by 5 plus beta whole thing divided by 2, or 6 minus 14 by 5 is equal to beta, or beta will be 20, this will be 30 minus this will be 16 upon 5. That's your value for beta. So your focus comes out to be 12 by 5 and 16 by 5. Now, the equation of the ellipse will be, okay, it's given as this. Eccentricity, I have to take out of the ellipse, which is given by the equation x square upon this y square upon this is equal to 1. You are given a is greater than b. So this ellipse is horizontal ellipse because a is greater than b. So eccentricity is given to you as 1 by root 2, right? And centricity is root of 1 minus b square upon a square. Eccentricity is this. So you have eccentricity square is equal to 1 minus b square upon a square. This is 1 by 2 is equal to 1 minus this. Or you have b square minus a square is equal to 1 minus 1 by 2, which is equal to 1 by 2. Or you have b square is equal to a square upon 2. Right? Now, you are given the equation of the ellipse as this one, right? And I also have the equation b square is equal to this. So this equation of the ellipse, which is given by this, now this can be written as, since it is having the focus as this alpha and beta, so it is passing through. You're given that this ellipse is passing through the focus of the parabola. So now this equation, it can be written as this was focus was what? Focus is 12 by 5 and 16 by 5. Now this passes through this focus. That means x and y I can use as this. So 12 square, 144, 5 square, that is 25 into a square plus y square, that is 16 square, which is 256 upon 25. B square can be written as a square by 2, which will go in the numerator. And this will come out to be 144 upon a square, 25 a square, plus this will be 600, no, this will be, wait, 2, 1 and 5. A square, this is equal to 1, or adding both of them, you will get 656 is equal to 25 a square, or a square is equal to 656 upon 25. So you will get the value of a as root of 656 upon 5. This is your value for a. And the corresponding value for b was, we calculated b square was equal to a square upon 2. So b square is equal to 656 upon 25 into 2, or this is equal to 328 upon 25. That's your value for b square. Now you have to, what you had to find out was a square of the length of the latest rectum. Latest rectum is, for an ellipse, is given by 2b square upon a. 2b square upon a, and 2b square was 328 upon 25. A's value was equal to 656 under the root, multiply by 5 over here. So this will cancel 5, and this will be equal to, this is latest rectum, right? You have to find out the square of the length. Okay, I'll do the squaring also. So let's say this is the latest rectum L. This is equal to, okay, this can be written as, wait, this can be written as 2 into 328 upon 5 into 656. Let's do the squaring now. So this will also be squared. This will be equal to 2 into 328 into 2 into 328 divided by 25 into 6, 5 and 6. This will cancel, and you will have 656 upon 25. This is the answer to the question. Now let's check with the options. You have 656 upon 25. Option D is the right answer. Hope you're clear with this. Let's move to the next question then. Question number 8, the temperature T of the body at the time T is equal to 0 is 160 Fahrenheit and decreases continuously as per the differential equation given by this, where K is the positive constant. T15 is equal to 120 Fahrenheit. What is T45 equal to? So you have the equation dt, d capital T by small t is given by this, or you can write it like dt upon t minus at is equal to minus k into dt. Let's integrate. integrating, you will have log of t minus 80 is equal to minus kt plus c. Now you're given that the temperature at when t is equal, time is equal to 0, temperature is 160 degree. So this is given to you. That makes log of 80, 60, 160 minus 80, this gives me 80 only, 0 plus c. So c's value is equal to log of 80. So now this equation becomes log of t minus 80 is equal to minus k into t plus log of 80. So let's take it on the left hand side. You will have kt log t minus 80. If I take it on this side, this will be divided by 80 is equal to minus k into t. Or this can be written as log t minus 80 upon 80. I'm taking the whole thing under the mod. This can be written as e raised to power minus kt. Okay, if I remove the log from here, let's remove the log from here. So this is equal to this. And you are given that at T15, that is 15, when time is equal to 15, temperature is equal to 120. So this gives me 120 minus 80 upon 80 is equal to T minus K into 15. So I have to get the value of K as well. This is 40 upon this. That gives me 1 by 2 is equal to e raised to power minus 15K. Right? Or taking log on both sides, you will have log 1 by 2 is equal to log e raised to power minus 15K. And I hope, right? Yeah. So I can write it like this. 2 raised to power minus 1 is equal to minus 15K, because log e raised to power something becomes that variable only. So this becomes a minus natural log 2 is equal to this, or this is the value for K. This will be log 2 upon 15, right? Now, what does your equation becomes? Where was your equation? There, this is your equation. Now, this equation will be this equation now will become, I got the values. Okay, this was t minus 80 divided by 80 is equal to e raised to power. That was k t it was, which is equal to k's value. I will put log 2 upon 15 into t. And now what you have to find out was T45, that the temperature at 45, like when the time is equal to 45. So t minus 80 upon 80 whole under the mod is equal to e raised to power log 2 upon 15 into 45. This is equal to, it gives me this. So this is equal to log, this is natural log 2 into 3, right? So this makes it e raised to power 3 log 2, or this is equal to e raised to power log 2 raised to power 3, or this is equal to 8. So you have t minus 80 upon 80 is equal to 8, or here you will have t minus 80 is equal to this. One thing I did was I forgot this minus sign to write. So it will be minus over here. So this will be minus, this will be minus, and here will be 2 raised to power minus 1. So this will be 2 raised to power minus 3, and this will be 2 raised to power minus 3, that is equal to 1 by 8 only. So this is equal to 1 by 8, this is equal to 1 by 8, and I'll rewrite this thing 1 by 8 into 80, which is equal to 10. So T will be equal to 90 degree Fahrenheit. This is the answer to the question, 90 degree Fahrenheit, option C. Hope you're clear with this. Let's move to the next question then. Question number 9, let second, 8th, 44th terms of a non-consistent AP be respectively first, second, third term of the GP of the first term of the AP is 1. This is Okay, 1. Then the sum of 20 terms is equal to. Let's read the statement once again. Second 844 term of an inconsistent AP. B respectively. First, second, third term of the GP. If the first term of the AP is 1, comma, then the sum of, see the comma was not there, so I got confused. Fine. Then the sum of the first 20 terms is equal to. So here you're having, first of all, you're having an AP. So second term, which is given by A plus D. Eighth term, A plus 7D. And 44th term, A plus 43D. This is equivalent to first term of the GP, that is A. Not let's take A, let's take some another variable. Let's say GP1, 2, and GP3. Right. Now, if the first term of the AP is 1, so this becomes 1 plus D, 1 plus 7D, and 1 plus 43D. Okay, you know in the GP, the ratios of like GP2 upon GP1 is equal to GP3 upon GP2. So that means from here, because they are equal to GP1, GP2, GP3, so you will have 1 plus 7D upon 1 plus D is equal to 1 plus 43D upon 1 plus 7D. Or this will make 1 plus 7D whole square is equal to 1 plus D into 1 plus 43D. So let's open up. You will have 1 plus 49D square. 14D is equal to 1 plus, this will be 44D plus 43D square. You will have 6D square minus 30D is equal to 0. 60, let's take common, D minus 5 is equal to 0. That gives you either D is equal to 0 or D is equal to 5. D can't be equal to 0, of course, then we'll take the D is equal to 5. So, and you're already given that A is equal to 1. Now, what you have to find out in the question, the sum of the first 20 terms is equal to. What you have to find out is S20. This is given by Sn is given by N by 2. 2a plus n minus 1 into d. We have everything. This is 20 upon 2, 2 into 1 plus n minus 1 into d. So this will be 10 to 95 and this will be 97, 970. This is the answer to the question. 970, option D stands to be the right answer to the question. Hope you're clear with this. Let's move to the next question then. Question number 10, let every real function from real numbers to 0, comma infinity be strictly increasing such that the limit of f of 7x upon x when x approaching infinity is equal to 1. You have to find out the value for this limit. Okay. So here, according to the given question, this is a required graph, and you can easily say that fx is less than equal to f of 5x is less than equal to f of 7x for all x greater than 0. So here, x is less than 5x is less than 7x because the graph is increasing like this. This makes 1 is less than equal to f of 5x divided by f of x, which is less than equal to f of 7x divided by f of x. Now, as x approaches infinity, f of 5x upon fx, this will approach to 1. So the limit x approaching infinity, f of 5x upon f of x minus 1, this will be equal to 0 because minus 1 is equal to 0. So that makes B option to be the right answer. Option B. Hope you're clear with this. Let's move to the next question then. Question number 11. This question says the area of the region bounded by this parabola and this parabola is equal to. Let's understand the parabolas over here. First of all, you are having parabola 4x minus x squared. This parabola looks something like this because it's passing through the origin. So this is somewhat like this parabola. Okay. And the second parabola is given by 3y is equal to x minus 4 whole square. This looks something like this over here. It will pass like this. All right. So this is the required shaded area that you need to find out. For that, let's find out, first of all, find out the point of intersection of the two parabolas. So here you have y is equal to this. Let's fill in this equation to get the 2 points of intersection. You have 3 into 4x minus x square is equal to x minus 4 whole square. Or you have 3 into, this will be 12x minus 3x square is equal to x power 4, 16 minus this, or you will have minus 4x square plus 20x minus 16 is equal to 0. X square minus 5x minus 4 is equal to 0. Plus 4 is equal to 0. Multiplying both sides by minus 5. Sorry, dividing both sides by minus 4. You will have this equation. So here will be x 4x, x square minus 4x minus x plus 4 is equal to 0. X minus 4 minus x minus 4 is equal to 0. Or you will have x is equal to 1 or 4. So for x is equal to 1, the value of y will be given by y was equal to 4x minus x square. So when x is equal to 1, y will be 4 minus 4, y will be equal to 4 minus 1, that will be 3. And for 4, this will be equal to 16 minus 16, that is equal to 0. Okay, so the 2 point of intersections are 1 comma 3, which is this point. Let's say this is a point, and the second one over here. Actually, the figure is not up to the mark. So this is the point of intersection on the axis, x-axis, which is 4 comma 0. Let's say this is the point P. Now, area of the shaded region will be given by area of shaded region. This will be given by integral of limit 1 to 4, area bounded by the curve 4x minus x squared dx minus area bounded by the curve x minus 4. This is minus integral of x minus 4 whole square upon 3 dx 1 to 4 again, right? So that means I have to like find out the area, this one, first of all, the whole one, then I will be subtracting the area bounded by this to get the required area. This is given by 4x square upon 2 minus x power 3 upon 3 minus, I'm combining both of them, they are having the same limits, okay? All right. So this will be x minus 4 power 3 upon 3 into 3. That will give you 9. Limits 1 to 4. So this will give me 64 upon 2 minus 64 upon 3 minus 4 upon 2. 1 upon 3, 27 upon 9. This is gonna give me, on solving, 27 minus 21, which is equal to 6. So this is the answer to the question, option C. Hope you're clear with this. Let's move to the next. Question number 12. Let the mean and the variance of 6 observations, these be 55 and 194 respectively. A is greater than B. You have to find out the value of A plus 3B. So the given series A, B, 68, 44, 48, and 60. You are given the mean, which is A plus B plus 68. This is equal to 55. So 55 multiplied by, these are the 6 terms, multiplied by 6, which is equal to 330. This will give you 220 plus A plus B is equal to 330, or you will have A plus B is equal to 110. Let's say this is equation 1. Also, you are given that variance is 194. So variance is given by summation xi minus x bar whole square divided by the number of terms. Right, this is equal to 194. So summation xi, we just okay, summation xi minus x bar. So this will be, the first term was A, and the mean is 55. So A minus 55, B minus 55 square, 68 minus this, 48, 68, then I have 44. minus 65 square. Then you have 48 minus 55 square. 60 minus 55 square. This is equal to 194 into 6 because the n was equal to 6. Okay, so let's open this up. You will have, this is a square plus 55 square minus 110a, b square plus 55 square minus 110b. This is gonna give you 13, so 169, 121, 49, 25. This is equal to 1164. Or this will be a square plus b square. 55 square, this is 3025. So 3025 plus 3025, this is 6050. Right, and minus 110. A plus b was, what was a plus b? It was 110 only. So this thing plus, that's gonna give you, and let's add all of them. 364 is equal to 1164. This gives me a square plus b square is equal to 1164 minus this minus 6050 plus 12100. On solving this whole thing, you will get 6850. This is the value for a square plus b square. Okay, now you have two equations. One was a plus b is equal to 110, and the second you have a square plus b square. So on solving both of them, let's say a is equal to 110 minus b. So here you will have 110 minus b whole square plus b square is equal to 6850. You will solve this whole, it will be a quadratic equation. No lengthy calculations are there, nothing else. You have to pay attention to the calculations. This will be 12100 plus b square minus 220b plus b square. This is equal to 6850. On solving this, you will have 2b square minus 220 plus 100 minus 6850 is equal to 0. You will get the value of b as 35 on solving, and for b is equal to 35, you will get a as 75. Okay, so you got the values for a and b. You had to find out a plus 3b. That's 35 plus this, which makes it 180 to be the right answer to the question. Option C. Hope you're clear with this. Let's move to the next. Question number 13, if the function f given by minus infinity to 1 to a to b is defined by this is 1, 1 and on to, then the distance of the point P from this line is equal to. See, again, the question is divided in two parts. From the first part, I'm going to get the value of a and b, and then I'll put that value in the P to get my answer, which is actually your second part of the question. So here I'll start with the function. It's given as e power x cube minus 3x plus 1. Let's differentiate. You will have ex cube minus 3x plus 1 into, this will be 3x squared minus 3. This can be written as this. I'm taking 3 common. X squared minus 1 can be written as x plus 1 into x minus 1. See what I did over here? This can be 3 taken common. X squared minus 1. This is x plus 1 into x minus 1. This is your f dash x. Now for the given interval for x belonging to minus infinity to minus 1, this derivative is greater than equal to 0. That means fx is the increasing function. Therefore, what will be a? A will be equal to e raised to power minus infinity, which is equal to 0, which is equal to f of minus infinity. And b will be given by e raised to power minus 1 plus 3 plus 1, which is e power 3, which is nothing but f of minus 1. So the point b, which was given by, what was it? 2b plus 4 comma a plus 2. So this point is given by e power 3 plus 2, 2, and a was equal to, so this is equal to 2 and a. This is your point B, P. Now, this is your point P, and this is your line x plus e power minus 3, y is equal to 4, x plus e power minus 3 into y minus 4 is equal to 0. So you have to find out this D. All right, you got the point B already. This is 2e power 3 plus 4 comma 2. So easy as that. So you will have D as this will be 2e power 3 plus 4 plus 2 into e power minus 3 minus 4 whole divided by root of 1 plus e raised to power minus 3 square, which is square. Okay, so multiplied by 2. This will be given by, this is equal to, on solving, let's write it clearly. This is 2e power 3 plus 4. This will cancel. So here will be plus 2 upon e power 3. This whole is 1 plus e power minus 6. So this is given by this. That's 2 taken outside. This will be e power 6 plus 1. And e power 3 will cancel from the numerator and denominator. This will be e power 6 plus 1, which is equal to this. These are the same. This will be 2 into root e power 6 plus 1. So this is the answer to the question. And here it is. We have the first option. This is the right answer. Hope you're clear with this. Let's move to the next question. Consider the function f from 0 to infinity to r defined by fx is equal to this if m and n respectively are the number of points at which the f is not continuous and not differentiable. What is the value for m plus n? You're having the function fx is equal to e power minus log of x, where x belongs to 0 to infinity. So this fx will be equal to e power positive log of x for x belonging to 0 to 1, and for the further ones it will be minus this belonging to 1 to infinity, right? And that means, e raised to power log of x, this will be equal to x only and minus x only. No, not minus x, this will be 1 by x, because this will be x raised to power minus 1. Okay, for x belonging to 0 to 1, and here x belonging to 1 to infinity. So the graph for this will look something like this. It will pass through the origin, straight line from here, and it will pass through the origin straight line from here till this point, and then it will go like this. Okay, so this is the point, x is equal to 1. So that means fx is continuous graph. No breakage is there for all x belonging to real numbers. So that makes your m is equal to 0. And this is not differentiable at x is equal to 1. So this is not differentiable at x is equal to 1. So that makes n is equal to 1. This makes m plus n is equal to 0 plus 1. That makes 1 as the right answer. Option C is the correct one. Hope you are clear with this. Let's move to the next question, number 15. It says the number of solutions of the equation e raised to power sine x minus 2 e raised to power minus sine x is equal to 2 is. So here, let's write down the equation e power sine x minus 2 e power minus sine x is equal to 2. Let's put e power sine x is equal to t, provided t is greater than 0. So this will be t minus 2 upon t That's equal to 2. If I use this equation, so this is the one, and t square minus 2 upon t is equal to 2, or you will have t square minus 2t minus 2 is equal to 0. Here you will have a I can write it like this: t square minus 2t plus 1 is equal to 3, which is t minus 1 whole square is equal to 3. This gives me t is equal to 1 plus minus root of 3. Or root of 3 is equal to 1.73. So t is equal to 2.73, or it is minus 0.73. This is rejected because t is supposed to be positive. We already discussed this thing in the starting only. T is positive because we are taking e raised to power sin x is equal to t. So that means I'll be taking t is 2.73, which makes e raised to power sin x is equal to 2.73. Taking log on both sides, log e raised to power sin x is equal to log of 2.73. This makes sin x is equal to log 2.73, which is greater than 1. So it has no solution. So that makes no solution to be that is 0, to be the right answer to the question. Hope you're clear with this. Let's move to the next question. Question number 16, if A is equal to sine inverse sine 5, B is equal to cos inverse cos 5, then A square plus B square is equal to. So here having first A is equal to sine inverse sine 5. That makes A as 5 minus 2 pi, and B is given to you cos inverse cos 5. That makes B is equal to 2 pi minus 5. You have to find out this. So this is 5 minus 2 pi square, 2 pi minus 5 square, which is equal to twice of 5 minus 2 pi whole square, 2 into 25 plus 4 pi square minus 10 pi, or this will be 8 pi square plus 50 minus 20 pi. So this is the answer to the question: 8 pi square minus 20 pi plus 50. Option C is the right answer. Hope you're clear with this. Let's move to the next question then. Question number 17, if for some value of m and n 6cm plus this whole expression is greater than 8c3, and this ratio, this n minus 1 p3 ratio n p4 is equal to 1 is to 8, then this is equal to. Okay, so you are having, let's write it down, 6cm 2 into 6cm plus 1 plus 6cm plus 2. It's a bit confusing the way they have written. Okay, this is greater than 8c3. So you have 6cm plus this will be 6cm plus 1. I'm opening 6cm plus 1. 6cm plus 2 greater than 8c3. This is what? See, this will be given by 7cm plus 1 plus 7cm plus 2 greater than 8c3, because I have combined these two and these two. Now, if I combine these two, 7cm plus 1 plus this will give me 8cm plus 2. Now, this is greater than 8c3. Looking at that, the only possible value for m is equal, because this is greater, that means m plus 2 is, m can be equal to 2. M plus 2 is greater than 3. So, m can be equal to 2 over here. Right, I got the value for m. Okay, now you're given that n minus 1 p3 ratio n p4, this is equal to 1 is to 8. Let's write n minus 1 p3 upon n p4 is equal to 1 upon 8. This gives me n minus 1 factorial upon n minus 4 factorial multiply n factorial into n minus 4 factorial is equal to 1 by 8. This will cancel and you will have n minus 1 factorial upon n into n minus 1 factorial is equal to 1 by 8. This gives me 1 by n is equal to this, or n is equal to 8. I got the value of m as 2, n is equal to 8. Now next, what I need to do in the equation, then you have to find out this. n p m plus 1 plus this. To find n p m plus 1 n plus 1 c m. This makes it 8 c3 9 c2. That's equal to 8 factorial, 3 into 5 factorial plus 9 upon 2 into 7 factorial. This gives it 336, and this will be 36. So the answer to the question 372. Here it is, option D. Hope you're clear with this. Let's move to the next question. Question number 18, a coin is biased so that the head is twice as likely to occur as tail. If the coin is tossed 3 times, then the probability of getting 2 tails and 1 head is. So let the probability, you are given that the probability that the head is twice likely to come as the tail. So that means the ratio of head to tail is equal to 2:1. So let's say probability of tail is equal to 1 by 3. So what will be the probability of head? It will be 2 by 3. Now the probability of getting 2 tails and 1 head. So 2 tails and 1 head will be 1 by 3 into 1 by 3 into 2 by 3. Now the coin is tossed 3 times, so this will be multiplied by 3. This will be 2 by 9. So this is the answer to the question, 2 by 9. Option A. Hope you're clear with this. Let's move to the next. Question number 19. Let A be the 3 by 3 real matrix such that A is A into 101 is equal to 2 into this. And A into this is equal to 4 into this. A into this is equal to this. We have to find out A minus 3I into XYZ. This is equal to 1, 2, 3. You have to find that this system is unique, exactly 2 solutions, no, or infinitely many solutions it is having. You are given that A is a 3 by 3 matrix. Let's say A is given by x1, y1, z1, x2, y2, z2, x3, y3, and z3. So you are given that A into 1, 0, 1, this is equal to, it is equal to 2 into this. This will be 2, 0, 2. Let's say, so A was equal to, A was x1, y1, z1. So it will be x1, y1, z1, x2, y2, z2, x3, y3, and z3. Multiplied by 101 is 2, 0, and 2. This will be x1, first row, first column, right? So this will give me x1 plus z1 and x2, z2, x3 plus z3. This is equal to 2, 0, 2. This gives me x1 plus z1 is equal to 2. This is 0 and this is 2 again. Okay. Similarly, you will solve rest of the equations for this one. Yeah, this and this. The corresponding values will be similarly A into minus 1, 0, 1, that's equal to minus 4, 0, 4. So A was equal to your x1, y1, z1, x2, y2, z2, x3, y3, and z3, minus 1, 0, 1. And this is minus 4, 0, 4. This will give me, on solving, minus x1 plus z1 is equal to 4 and minus 4, and x2 plus z2 minus x2 plus z2 is equal to this, minus x3 plus z3 is equal to 4. This, yeah, get these equations. And now let's say the third one is, let's name the equation. Okay, don't. Fine, the third one set is a into 0, 1, 0 is equal to this. A into, now, a into 0, 1, 0 is equal to 0, 2, 0. So this is x1, y1, z1, x2, y2, z2, x3, y3, z3. This 0, 1, 0, 0, 2, 0. This will be, on solving, this will give you, first of first column, y1, and this will give me y1 is equal to 0, y2 will be 2, and y3 will be 0. Now we have these equations. This is the first set. This is the second set and third set. These are the three sets. If you solve all of them using, this involves only the calculations using 1, 2, and 3. You will get the value of x1 as 3x, y1 0, z1 as -1, x2 0, y2 will be 2. See, I have done the calculations already and I have noted down the answer. So you just need to do the calculations, nothing else. Z2 is equal to 0, x3 is equal to -1, y3 is equal to 0, z3 is equal to 3. So now the A matrix will be given by, this was 3, 0, -1, 0, 2, 0, -1, 0, and 3. Okay, now A minus 3i. This will be given by, so A was this, 3, 0, 1, 0, 2, 0, -1, 0, 3, minus 0, no, 3, 0, 0, 0, 3, 0, 0, 0, 3. This is 3 into I matrix, identity matrix. I know, I hope you know that identity matrix is this. Okay, so 3 into this matrix will give you this, and A minus 3i, according to the question, A minus 3i into xyz is equal to 1, 2, 3 into xyz is equal to 1, 2, and 3. So this is your, it was, what was this? Okay, this comes out to be 0, 0, -1, 0, -1, 0, -1, 0, 0 into x, y, z, 1, 2, 3. So this will give me the matrix as -z, -y, -x. This is 1, 2, 3. This makes, this gives you z is equal to -1, y is equal to -2, as x is equal to -3. So this is the answer to the question. That means it is having a unique solution. Option A. Hope you're clear with this. Let's move to the next question. Question number 20, the shortest distance between the lines L1 and L2, where L1 is given by this equation and L2 is the line passing through these 2 points and is perpendicular to this line. is equal to. So first thing, you are having the equation of the line L1 as x minus 1 upon 2, y plus 1 upon minus 3, z plus 4 upon 2. And the line L2, this is passing through the points minus 4, comma 4, comma 3, and b minus 1 and 6, comma 3. So the equation of the line L2 will be given by x plus 4 upon this will be 1 minus 1 plus 4, that is equal to 3. Similarly, y minus 4, 6 minus 4, that's equal to 2. Z minus 3, 3 minus 3, which is equal to 0. Now, this is perpendicular to line x minus 3 upon minus 2, y plus 1 upon minus 3, z plus 4 upon 2. So, therefore, the shortest distance formula is given by L1, L2. This is L1, L2 vector dot product with N1 cross N2 divided by the magnitude of it. First of all, what is L1, L2? For the L1, L2, this is given by x plus 4 minus x minus 1. This will be given by 5 I cap. Give me a minute. This will be minus 5 I cap plus 5 j cap plus 7 k cap. How is this? See over here, this will be x minus 1 minus of this will be same thing. X minus 1 minus x minus 4, this will be equal to minus 5. Similarly, y minus 1 minus y minus 4, this will give you plus 5j. Z plus 1 minus z minus 3, this will give you 7k. This is for L1, L2. This is a distance L1, L2. Now, the cross product of N1 and N2. This is given as I, J, and K. The vector form for L1 is equal to 2 minus 3, 2. And this is equal to 3, 2, and 0. So this is given as I into minus 4 plus minus j into minus 6 plus k into 4 plus 9. This gives me minus 4i plus 6j plus 13k. Let's find out the magnitude also for this vector. This is equal to 4 square, which is equal to 16, and this is 36. This is 169. Okay, now the shortest distance. Okay, this is equal to, on totaling, this is equal to 221 under the root. So the shortest distance is given by, this is minus 5i plus 5j 7k dot product with, this was minus 4i plus 6j plus 13k whole thing divided by root of 221. This will give me, the numerator will give me minus 4 and this 20 plus 30 plus 91 upon root of 221, which is going to give you 141 divided by this. This is the answer to the question. 141 divided by this. Option C is the right answer. Hope you're clear with this. Let's move to the next question. Question number 21. It says the modulus of 120 upon pi cube integral of this function is equal to, let's say this function is equal to I, and this integral is equal to I. This is 0 to pi x squared sine x cos x upon sine power 4x cos power 4x dx. So I'll be applying, let's do one thing. King's rule. King's rule, you hope you know, limit a to b fx dx can be written as limit a to b integral of a plus b minus x dx. So if this is equal to I will say it as 0 to pi x square. This will be given by 0 plus pi minus x square. Yeah, multiplied by sine pi minus x cos pi minus x, whole thing divided by sine pi minus x power 4 cos power 4 pi minus x dx. So this is equal to this. I is equal to limit 0 to pi, and here will be this. I'm not touching, let it be like this only. All right, sine pi minus x, this will be sine x, because this lies pi minus x lies in the second quadrant, and in the second quadrant sine is positive, cos is negative. And this is gonna give me sine x, and this will be minus cos x divided by, this will be sine power x, and this is cos power x only. Okay, because sine pi minus a is equal to sine a, and cos pi minus a is equal to minus cos s. This pi doesn't change the tangent. Trigonometric ratios, they doesn't change it. So this is, let's say this is 1, and let's say this is 2. So adding, or you'll say, I'll write first of all this 2 properly. Let's take this minus outside. This is 0 to pi minus x square into sine x cos x upon this dx. Let's say this is 2. Now I take 1 and 2. You will have 2I is equal to limit 0 to pi sine x cos x upon this. This is common in both of them. So I will take it common, multiplied by, here was x square. See, in this one, it was x square. And here you are having minus of pi minus x square. Minus pi minus x square dx. So this 2I is equal to 0 to pi. This is, if I open this one, you will have a pi, I'll take common, 2x minus pi. See, x square minus pi square minus x square plus 2 pi x. This will cancel, so I have taken pi common, and the rest thing, let it be. All right. So now again, this is an even function, so I can write it like this. 2, I'll take outside, limits will be changed from 0 to pi by 2. And here will be pi, this is a constant, I'll keep it outside. So 2 pi over here, and here will be 2x minus pi into sine x cos x upon sine power 4x cos power 4x dx, that's equal to 2I. So 2 and 2 will cancel. You will have I is equal to pi, 0 to pi by 2, 0 to pi by 2. This is minus 2x sine x pi by 2. This is 2 into x. Now I'm again applying the King's rule again. So x will be changed in 0 plus pi by 2 minus x. Okay. Minus pi. This thing. And again, sine, this will be sine x only, because, okay, no, sine pi by 2 plus x minus x. Sine pi by 2 minus x into cos pi by 2 minus x, whole thing divided by sine pi, sine power 4 plus cos power 4 pi by 2 minus x dx. Okay, so this will be I is equal to limit 0 to pi by 2. This pi and this pi will cancel. You will have minus 2x over here. And now sine will be changed into cos. Cos will be changed into sine because sine pi by 2 plus, minus any angle is equal to cos of that angle. This lies in the first quadrant, and cos will also change. So the signs will not change. Only sine will be changed into cos, and cos will be changed into sine. Divided by, this will be cos power 4x, sine power 4x, and dx. All right. Again, I'll be doing, this is adding both of them before applying the King's rule. This and this equation, let's say this is equation 3 and this is equation 4. Adding 3 and 4, you will have 2i is equal to integral pi outside 0 to pi by 2. This is 2x minus pi, and here is this. So this will be only minus pi will be left. Okay. Sine x cos x divided by sine power x, sine power 4x cos power 4x dx. Okay. This will be, now I'll be taking it outside, minus pi square 0 to pi by 2. I'll do one thing. I'll multiply the numerator and denominator by 2. So this will be 2 sine x cos x. Right. Divided by sine power 4x cos power 4x dx. That's equal to your 2i, or you will have I is equal to minus pi square upon 4. This is integral 0 to pi by 2 sine 2x upon sine power 4 plus cos power 4 dx, or this is equal to minus pi square upon 4 integral 0 to pi by 2. This is 2 tangent x into secant square x upon tangent power 4x plus 1. What I have done, I have divided the numerator and denominator by cos power 4x. Okay. So this becomes 2 tangent x secant square x upon this. That means I is equal to minus pi square by 4, and this is what this is equal to tangent inverse tangent square x, limit 0 to pi by 2, right? Because here you are having this mm, tangent square x. Ultimately what I can do over here, if you put in this, I'm just solving for the shorter one. If I put tangent square x is equal to 2t is equal to t, that makes 2 tangent x into secant square x dx is equal to dt. So using that, and this denominator will be 1 plus tangent square x square. This is nothing but the tangent inverse of t, that is tangent inverse of tangent square x. Hope you're getting this thing. And now let's fill in the limits only. This is equal to minus pi square upon 4 tangent inverse tangent square pi by 2, right? Minus tangent inverse tangent of 0. Don't do this thing. I'll directly fill in. This is equal to minus pi square upon 4. Tangent, this will be, let's keep to this only. This will be minus pi by pi square upon 4. This will give me tangent inverse of infinity minus 0. This is equal to minus pi square upon 4 into pi by 2, which is minus pi cube upon 8. So this is the value for your I. I comes out to be minus pi cube upon 8. You had to find out was 120 upon pi cube into I. So 120 upon pi cube into minus pi cube upon 8. This gives me 15. So this is the answer to the question 15. Hope you're clear with this. Let's move to the next question. Question number 22. Let ABC be the length of three sides of the triangle satisfying this condition is equal to 0. If the set of all possible values of x in the interval alpha beta, then what is the value for this expression? You are given the condition as a square plus b square into x square minus 2b a plus c into x plus b square plus c square is equal to 0. Let's open up the brackets. You have a square, x square, b square, x square minus 2ab x 2bc x b square c square is equal to 0. Let's combine the terms a square x square minus 2abx plus b square. And then you have plus b square x square minus 2bcx plus c square is equal to 0. This is the perfect square for ax minus b, and this one is bx minus c whole square is equal to 0. Now, these are two perfect square which can never give you a negative value. So if the sum of them is equal to 0, this is possible only in the case when ax minus b is equal to 0 and bx minus c is equal to 0. Here you have x is equal to b upon a or x is equal to c upon a. From here, you have b is equal to a into x, and from here you have c is equal to a into x. So b and c, they both are equal. Wait, there was no, sorry, there is supposed to be b and this is equal to this. Okay, so you have b is equal to ax and c is equal to bx. Also, these two terms are equal. So from both of them, you have b upon a is equal to c upon b. This gives me b square is equal to ac. Okay. Now you're given that ABC, they are the length of the three sides of the triangle. So that means if I follow the triangle inequality, you have the three conditions. Sum of two sides of the triangle, sum of two sides of the triangle is always greater than the third side of the triangle. So that means a plus b is greater than c, b plus c is greater than a, or c plus a is greater than b. And I can write down b like you had b is equal to ax. So this will be a plus ax is greater than c. C will be written as bx. So, okay. For b was equal to ax, this can be written a plus ax is greater than ax square. From here, dividing both sides by a, you will have 1 plus x is greater than x squared, or x squared minus x minus 1 is less than 0. Now the second inequality says, I hope you know that I have used like p was equal to ax, so bx will be equal to ax square, right? Now the second inequality says that b plus c is greater than a. Again, b was equal to ax and c was equal to your bx greater than a. This is ax plus ax square greater than a, dividing both sides by a, 1 plus x square greater than x plus x square greater than 1. Here, from here, you will have x square plus x minus 1 is greater than 0. And from here, we had to see as ax square plus a is greater than ax. So this is dividing both sides by a. You will have x square plus 1 is greater than x, or x square minus x plus 1 is greater than 0. This is a perfect square for this. No matter what, this is going to be positive for all the values of x. So this is always true. Let's pick up this. Now, these two inequalities. By the quadratic formula, the roots will be given by x is equal to minus b plus minus root of b square minus 4ac upon 2a. Here, in this case, b is equal to minus 1, a is equal to 1, and c is equal to minus 1. So that means you will have a as x as it will belong to, that will be equal to x will be equal to 1 minus of minus 1. This will be 1 minus 1 square. This is 1 minus 4 AC. So minus 4 into minus 1. This is going to give me plus 4 upon 2. This is equal to 1 plus minus root 5 upon 2. So that means x can have two values. X will belong to this will be 1 plus root 5 upon 2 and 1 minus root 5 upon 2. Now, similarly, let's move to the second one. Here, again, you have x is equal to minus 1 plus minus root of 1 minus 4. Minus of minus 4, this will be plus 4 divided by 2. So, this is equal to minus 1 plus minus root 5 upon 2. So, that means the two values can be equal to root 5 minus 1 upon 2, and the second one will be root 5. Actually, this will be minus root 5 minus 1 upon 2 because you are having inequality over here. So, this can be written as root 5 plus 1 upon 2, the positive ones. Okay. See, because I'll just explain this thing. Otherwise, it should have been minus root 5 minus 1 upon 2. But you can write this equation as minus x square minus x plus 1 is less than 0. So following that, you will get this also as one of the root. Okay. So combining both of them, you will get x belongs to root 5 minus 1 upon 2 root 5 plus 1 upon 2. All right. So we over here as alpha and beta. So this means this is your alpha and this is your beta. Let's find out the alpha square plus beta square. You have to find out the 12 into alpha square plus beta square. This will give me 12 alpha square. This is root 5 minus 1 upon 2 whole square plus root 5 plus 1 upon 2 whole square. This is equal to 12. This will be 5 plus 1 minus this whole LCM. This will be 4 in the denominator. And this will be 5 plus 1 plus 2 root 5. And these two terms, they will cancel out. You will have, this will cancel 3. So you will have 3 into 12, which is equal to 36. So this is the answer to the question 36. Hope you're clear with this. Let's move to the next question number 23. It says let A be this point minus 2 minus 1 and B be the point C. C this B be the point 1 comma 0. Question number 23, let A be the point this, B be the point this, C be this, and D be this. These are the vertices of the parallelogram ABCD, which is drawn over here. If the point C lies on the line this, so that means this line AC, you are given the equation for this line AC as 2x minus y is equal to 5, and also you are given that the point D lies on the line 3x minus 2y is equal to 6. You have to find out alpha plus beta plus gamma plus delta. So basically, I need to find out the coordinates for C and D. D and C, I need to find out the coordinates. First thing, alpha and beta lies on 2x minus y is equal to 5, and gamma and delta lie on the line 3x minus 2y is equal to 5. This is equation 1 and 2. From the first one, you have 2 beta minus 2 alpha minus 2 beta. 2, see over here, this is 2 alpha minus beta is equal to 5. And from the second one, you have this is gamma x 3 gamma 3 gamma minus 2 delta is equal to 6. From here, you will have the value of delta as 3 gamma minus 6 upon 2. And from this equation, you have the value of beta as 2 alpha minus 5. This is the value for delta. Let's write it over here. Delta was equal to 3 gamma minus 6 upon 2 and beta was equal to 2 alpha minus 5. Now, you know one thing, the property diagonals of the parallelogram bisect each other. That means the midpoint of BD is equal to midpoint of AC. Diagonals of parallelogram bisect each other. So that means midpoint of BD is equal to midpoint of AC or CA, right? And BC is having BD is having the midpoint as a what was the coordinates? BD. This is 1 plus gamma upon 2, and let's write it over here. 1 plus gamma upon 2. This is for the x coordinate I'm solving. Let the midpoint be given by M. So x coordinate for the point M is given by, let's say this is the midpoint. And the x coordinate will be given by 1 plus gamma upon 2 for the BD. And for the CA, it will be given by alpha minus 2 upon 2. That gives me 1 plus gamma is equal to alpha minus 2, or gamma is equal to alpha minus 3. And let's go for the y coordinate for M. Y coordinate of the point M is given by, this will be delta plus 0.2 is equal to beta minus 1 upon 2. This gives me delta is equal to beta minus 1. Now, your gamma and delta, they lie on this. Let's say this is, okay, second equation. This lies on the second equation. So you have 3 gamma minus 2 delta is equal to 6, or this will be gamma, we just said that's alpha minus 3 alpha minus 3 minus 2 beta minus 1 is equal to 6. This gives you 3 alpha minus 2 beta is equal to 13, or 2 alpha minus beta is equal to 5 from here, from this equation. 2 alpha minus beta is equal to 5. So I have the two equations. Let's solve for this. This one solving, let's multiply with this 2. So you will have these two equations will become 3 alpha minus 2 beta is equal to 13, or 4 alpha minus 2 beta is equal to 10, minus plus minus, they will cancel. Minus alpha is equal to 3, or alpha comes out to be minus 3. So if I put in any of these equations, you will get the value of beta as minus 11, and your gamma was equal to, gamma was alpha minus 3. So this becomes, gamma makes to be minus 6, and this similarly delta, which was equal to beta minus 1, this comes out to be minus 12. Let's write down once again. You had alpha as minus 3, beta as minus 11, gamma delta as minus this, and sorry, gamma as minus 6, and delta as minus 12. You have to find out alpha plus beta plus gamma plus delta. This is delta. This is equal to mod of minus this, minus 6, minus 12, which will be 32, because mod minus sign will go away. So this is the answer to the question. 32 is the right answer. Hope you're clear with this. Let's move to the next question, number 24. Let the coefficient of x bar n, x bar r in the expansion of this expression. Let's look at the expression carefully. This is a single term. This is in the multiplication. This is in the multiplication, and so on. The last one is also a single term. B A R. So the summation from R is equal to 0 till NAR is given by this, where beta and this gamma belong to natural numbers. You have to find out the sum of squares of beta and gamma. So let's write this expression once, make it clear. This is given x plus 3 raised to power n minus 1, x plus 3 raised to power n minus 2 into x plus 2, x plus 3 raised to power n minus 3, x plus 2 square, so on till x plus 2 raised to power n minus 1. I'll be taking x plus 3 raised to power n minus 1 common. Here will be 1, and this one will give me x plus 2 upon x plus 3 plus x plus 2 square, x plus 3. So on, the last one will be x plus 2 raised to power n minus 1. And the denominator, this is nothing. Okay, denominator will be x plus 3 n minus 1. Now this is what the inside. This is a GP with the first term as 1 and the common ratio as x plus 2 upon x plus 3. Right? So then this expression becomes x plus 3 raised to power n minus 1. The sum of the GP is given by a into 1 minus r raised to power n upon 1 minus r. Here a is equal to 1 minus r. This raised to power n upon 1 minus r. 1 minus x plus 2 upon x plus 3. This is equal to x plus 3 raised to power n minus 1. Here will be, let it be like this only, 1 minus x plus 2 upon x plus 3 raised to power n. The denominator will have x plus 3 minus x minus 2 divided by x plus 3. This is equal to x plus 3 raised to power n minus 1 into x plus 3, multiply 1 minus x plus 2 upon x plus 3 raised to power n. This bracket will be closed, divided by, here you will have 1, right? Okay. Right. So let's write it properly. This is equal to x plus 3 raised to power n multiply 1 minus x plus 2 raised to power n, x plus 3 raised to power n. Let's take the LCM again. You will have x plus 3 raised to power n. There will be x plus 3 raised to power n, x plus 2 raised to power n divided by this. So they will cancel and you will have x plus 3 is equal to plus 3 minus n, x plus 2 power n. Now let's get back. You have to find out the coefficient of x raised to power n in this expression. So the coefficient of x power n, x power r in this expression is given by NCR into 3 raised to power n minus r, minus this will be NCR into 2 raised to power n minus r. According to question, this coefficient is AR. And okay, so if you are given that summation r is equal to 0 till n AR is equal to this. Let's go on finding the summation. So summation r is equal to 0 till n NCR is AR is given by NCR 3 power n minus r minus NCR 2 power n minus r. This will be given by NC0 into 3 power n plus NC1 into 3 power n minus 1, NC2 into 3 power n minus 2, so on till NCN. Minus, you will have a NC0 into 2 power n, NC1 into 2 power n minus 1, so on till NCN. Let's write it bit down. So on till NCN. Okay, and see, this is nothing but 3 plus 1 raised to power n. Okay, 3 plus 1 raised to power n. This is 2 plus 1 raised to power n, which is equal to 4 raised to power n minus 3 raised to power n. Now, in the question, this is given equivalent to, it is given equivalent to beta power m minus gamma power n. This is beta power n minus gamma power n. This gives you beta as 4 and gamma is equal to 3. You have to find out the sum of beta square plus gamma square, which is equal to 4 square plus 3 square, that is equal to 25. So this is the answer to the question. 25 is the correct one. Hope you're clear with this. Let's move to the next question. Question number 25, let A be a 3 by 3 matrix and determinant of A is equal to 2. If n is given by determinant of adjoint of A 2024 times, then the remainder of n when divided by n is equal to. Here you are given that the determinant of A is equal to 2 and n is equal to adjoint of, determinant of adjoint of A. This is repeating 2, 0 to 4 times. You know that adjoint of A determinant is equal to A determinant square. So that means adjoint of determinant of adjoint of A. This 2024 times is equal to determinant of A, that is equal to 2 raised to power 2 raised to power 2024. Now you one thing that 2 power 2024, I can write it like this, 2 4 power 1012, and 4 can be written as 3 plus 1, this 1012, or see, this is nothing but 3k. This is equal to a multiple of 3 and remainder will always be 1. So this is equal to 3k plus 1, where k is odd. Therefore, determinant of adjoint A, this determinant is equal to 2 power 3k plus 1. This is equal to 2 into, yeah, this is equal to 2 power 3k into 2, or this will be 2 into 8 power k, right? This can be written as this is equal to 2 into 9 minus 1 raised to power k, which is equal to 9m minus 2, because this 2 when multiplied by 1, this will give you minus 2. So this is equal to sum 9p plus 7. If I add 9 to it, this will be 9p plus 7. So this gives me a remainder of 7 always. Remainder of 7, because this is a multiple of 9 and the remainder will be equal to 7. That makes 7 as the right answer to the question. Hope you're clear with this. Let's move to the next question. Question number 26, let A be this factor, B be this factor, and C be a vector such that this statement is right. A plus B cross C is equal to 2A cross B plus 24J minus 6K, and the dot product of this vector and the C vector is equal to minus 3. You have to find out the magnitude of vector C square. First one, I'll pick it up. A vector plus B vector plus C vector is equal to this 24j minus 6k. So let's say, first of all, a plus b, if I add these two vectors, you will have 5i, j, 4k. And let's say c vector is xi, yj, and zk. So cross product, okay, xi, yj, and zk, this is equal to a cross b. Let's solve a cross b also. A is this factor 3i to j plus k cross with 2i minus j plus 3k plus 24j minus 6k. This will give me I, j, and k. 514xyz is equal to twice of I, j, k, 3, 2, 1, 2, minus 1, and 3 plus 24j minus 6k. This will give me, on solving, the value as z minus 4y I minus j 5z minus 4x plus k 5y minus x is equal to twice of this will be giving me 6 minus plus 1 7i, and this will give me minus 7j, this will give me minus 7k plus 24j minus 6k. So this is equal to, I'll not touch the LHS, this is equal to 14 I cap and 10j minus 20k. So equating, you will have z minus 4y is equal to 14, 5 minus 5z plus 4x is equal to 10, and 5y minus x is equal to minus 20. These are the three equations. Now let's pick up this one also. You're having a minus b plus I. Now a vector minus b vector minus I cap dot product with c vector is equal to minus 3. A minus b, a was, what was a? Okay, 3i minus 2i, and over here this is plus I, not minus, right? So this will give me 2i 3j minus 2k dot product with xi, y, j, z, k is equal to minus 3. You will have a 2x plus 3y minus 2z is equal to minus 3. And you already had these equations 1, 2, and 3. Solving all of them, you will get the value of x as 5, y will come out to be minus 3, and z you will get 2. So these are the four equations. You can easily get the value of x, y, z from here, and you have to find out the modulus, the magnitude of the c vector. This is given by c vector came out to be, which was x, I, y, j, and z, k. This is 5i minus 3j plus 2k. So this will be 5 square minus 3 square and 2 square, which will give you root of 38, and you have to find out the magnitude of this square. That's equal to 38. So this is the answer to the question 38. Hope you're clear with this. Let's move to the next question. Question number 27, limit x approaching 0, a x square e power x minus this whole expression upon x square sin x is equal to 1. Then you have to find out value for this expression. So basically, a, b, c, these are the three variables that I need to find out. Let's write that over here. You are having limits x approaching 0, a x square e power x minus b natural log 1 plus x plus c into x into e power minus x whole thing divided by x square into sine x. Let's do one thing, limit x approaching 0. I'll do it over here only. I'll multiply the numerator and denominator by x. So this will be, the denominator will become x cubed sine x upon x. Okay. And now the numerator, this will be ax square into e power x minus b log e1 plus x plus c into x into this, and divided by, this is a x cube multiply this thing. See this, when limit x approaching 0, this thing turns out to be 1. So you have limit x approaching 0, a x square e x minus b log e1 plus x plus c x e power x whole thing divided by x cube into 1, so x cube, because this is equal to 1 when x approaches 0. Now let's open up e power x and 1 plus log 1 plus x over here. This is minus x. Okay. You will have here, this is equal to a x square e power x is given by 1 plus x square upon 2 factorial x cube upon 3 factorial so on minus b. This is x minus x squared by 2 x cube by 3 so on, and plus c x e raised to power minus x is 1 minus x plus x squared by 2 factorial minus x cube by 3 factorial so on. So that was your limit x approaching 0, limit x approaching 0. This is ax square. So this will give me c minus b into x. See, this is cx into 1 and bx. So c into b, c minus b into x, I have taken x common from here. Similarly, plus here will be, I'm concatenating x square coefficients. The x square coefficient will be a, and it will be plus b by 2 plus a minus c into x square plus a minus b upon 3 plus c upon 2 into x power 3 so on. I'm not interested in the higher values. I'll just drop it over here. This whole thing was divided by x cube over here also. Okay. Now you are given in the question that this is equal to 1, and that means this is a constant, no x coefficient is there, and the 1 is given by this only. When you will be dividing this expression with x cube, you will get 1. So I'm interested only in the first three terms. This will give me c minus b is equal to 0, b upon 2 plus a minus c is equal to 0, and a minus b upon 3 plus b c upon 2 is equal to 1. Right? That's this gives me b is equal to c. So if I fill in this equation, b is equal to c, this will be c by 2 plus a minus c is equal to 0, or a comes out to be minus c upon 2. Let's fill in this one. A is minus C upon 2, B is C, and this is C upon 2 only. B is, A is this. This will be plus, not minus. Right. So this will be C minus C by 3 is equal to 1. 2 by 3 C is equal to 1, or you will have C is equal to 2 by 3. We just saw over here that B is equal to C. So B is equal to 2 by 3. And we already have the C. So A is equal to C by 2. This gives me A is equal to 1 by C by 2. That is 2 by 3 upon this. C is equal to 3 by 2, and here the C will be equal to, A will be equal to 3 by 4. Let's write it properly once. You have A as 3 by 4, B is equal to 2 by 3, and C is equal to, this is equal to 3 by 2. Give me a minute. Let's erase this. So B is equal to 3 by 2, and C is also equal to 3 by 2. What you had to find out was A square plus B square plus C square, which is equal to 9 by 4, 9 by 4 square. And this will be 9 by 4. This will be 9 by 4, which is equal to 9 by 16. 9 by 4 plus 9 by 4, this is equal to 9 by 2. So on solving this, you will get 81 by 16. This is the answer to the question, 81 by 16. Hope you're clear with this. Let's move to the next question. Question number 28, a line passes through the point A and B given by these coordinates and the point P, A, B, C, where they are the non-negative integers. On the line AB is at a distance of 21 units from the point A. The distance between the point P and the point Q is. So here you have A point as 4 minus 6 and minus 2. The B point is 16 minus 2 and 4. You're given that, let's frame the equation for the line AB. It will be given by x minus 4, 6 plus y plus 6 and z plus 2 divided by, here will be 16 minus 4, which will be 12, minus 2 plus 6, 4, 4 plus 2, that is equal to 6. So this is the equation of the line. Now you are also given that distance of the point P from the point A is equal to 12 units. So this makes this equation as x minus 4 upon 6 upon 7, y plus 6 upon 2 by 7 is equal to z plus 2 upon 3 by 7. This is equal to 21. So now this point P, this lies on this wait, this is at a distance of 21 units. So this point P, x, y, z for here will be calculated as 21 into 6 by 7 plus 4. Y will be 21 into 2 by 7 minus 6. Z will be equal to 21 into 3 by 7 minus 2. All right. So you will get the value of x as 22, y will be equal to 0, and z will be equal to 7. This is your P coordinate. Actually, this is your ABC. So you have this as P point will be 22, 0, and 7. And this is your Q point, which was already given to you in the question, which is 4 minus 12 and 3. You have to find out PQ. No, PQ vector, PQ only. This is given by root of 22 minus 4 whole square minus 12 minus 0 whole square, 3 minus 7 whole square. So this gives me 18 square, that is 324, 12 square, 144. And this is 16, which gives me the 22 as the answer. So this is the answer to the question, 22. Hope you're clear with this. Let's move to the next. Question number 29. It says y is equal to yx with the solution for this differential equation for x lying between the first quadrant 0 to pi by 2. Y of pi by 4 is equal to 0. You have, okay, you are given if y of pi by 6 is equal to alpha, then what is the value for e raised to power 8 alpha? I will find out alpha. So I'll get my answer. So you have to find out in another ways. You have to find out y pi by 6. You are given y pi by 4 is equal to 0. Let's write the differential equation that is given over here. This is secant square x dx e power 2y tangent square x plus tangent x into dy is equal to 0. Or this can be written as okay, secant square x, dividing both sides by dy. So secant square x dx upon dy is plus 2 e raised to power 2y. Tangent square x plus tangent x is equal to 0. Let's put tangent x is equal to t. You will have secant square x dx upon dy is equal to dt upon dy. So this makes this expression as secant square into dx by dy. This is equal to dt upon dy plus e raised to power 2y into this is t square plus 1. This is equal to 0. Or dividing both sides by t square, you will have 1 by t square into dt by dy plus this will be 1 upon t square plus e raised to power 2y is equal to 0. Or I can write it like this, dt upon dy plus 1 upon t square is equal to minus e raised to power 2y. Let's put 1 upon t is equal to u. This makes minus 1 upon t square dt by dy is equal to du upon dy. Okay, so now this equation will become 1 upon t square dt. This is equal to minus du upon dy plus u is equal to e raised to power 2y. So here the integrating factor is equal to e raised to power minus y, right? So this makes the equation as now this equation will be u into e raised to power minus I y is equal to integral of e raised to power minus y into e raised to power 2y. Or you will have 1 upon tangent x into e raised to power minus y is equal to, this is equal to e raised to power y plus c. 1 by t, and t was equal to tangent x. So instead of u, I have written 1 upon tangent x into this. Now further, you are given, okay, fine. You are given that y pi by 4 is equal to 0. That means at x is equal to pi by 4, you have y is equal to 0. So tangent of pi by 4, this gives me 1 only. Let's write it over here. Multiply by e power 0 plus c. So c comes out to be 1. 1 to this. This is no, this is equal to, wait. This was equal to 1 is equal to 1 plus c. So c is equal to 0. Now this equation will become, now you will have the equation as 1 upon tangent x into e power minus y is equal to e power y, and c was 0. So I'm ignoring that. What you have to find out is y of pi by 6. So y of pi by 6, this is tangent of pi by 6 e raised to power, this will be given as e raised to power y upon this, or this will be, this is equal to e raised to power 2y. And tangent of pi by 6 is equal to 1 upon root 3, which is equal to root 3 only. This is equal to e raised to power 2y, right? Yes. So this is the one. And this was equal to alpha. Y is equal to alpha, right? It's given it's given over here that at y is equal to pi by 6, at x is equal to pi by 6, y is equal to alpha. So here y was equal to alpha. I will write it as e raised to power 2 alpha. And I think this is what we needed in the question. What was it? E raised to power 8 alpha. So I got e raised to power 2 alpha as root 3. If I want e raised to power 8 alpha, this is equal to e raised to power 2 alpha cube. That makes 3. Yeah. So this is to be, this should be this 4, because 2 alpha into 4, this is equal to 8 alpha. So this is raised to power 4, which is equal to 3 into 3. So the answer to the question is 9. So 9 is the answer to the question. Hope you're clear with this. Let's move to the next question. Question number 30. This is the last question of the paper. Let A is equal to 1, 2, 3 till 100 and R be a relation on A defined by xy belonging to R if and only if 2x is equal to 3y. Let R1 be symmetric relation on A such that R is a subset of R1 and the number of elements in R1 is equal to n. Then the minimum value of n is equal to. You are having the A set which contains 1, 2, 3 till 100 and now, what will be the elements of R according to the question? It should be 2x is equal to 3y. So R will contain 3 comma 2, 6 comma 4, 9 comma 6, 12 comma 8, so on and 99 comma 66. And R1 is a symmetric relation on A such that R is a subset of R1. So symmetric elements, they will be given by, this will be 2 into 33, which is equal to 66. So that means number of elements in R1 is equal to 66. This is the answer. Hope you are clear with this. So students, with that, we have completed all the 30 questions of the paper. And don't forget to visit our website, www.examsnet.com. Here you will find all the entrance exam question papers with their detailed PDF solutions. And you must download our app. The link is available in the description box for a better preparation of your exams. So students, keep shining, keep rising high. That's all for this paper. Best of luck. Bye.